BGP Confederation, CONFA, Confederation. What do you understand from this picture? You have AS inside AS. Look at this. This is the primary AS. This is the primary autonomous system number 2345, inside which you have secondary autonomous systems. This is Confederation. Confederation. Here, number of parties like AS2, AS4, AS5, AS3, they all form an alliance to form one big autonomous system called 2345, Confederation. Now, why we need this? What is the wrong in having as one autonomous? So, Confederation is having multiple autonomous systems joining together to form another big autonomous system. This autonomous system 2, 3, 4, and 5, they all join together and they work as one single autonomous system called 2345, BGP AS 2345. So you got a primary autonomous system called 2345, and you got secondary autonomous systems like 2 separate, 3 separate, 4 separate, or 5 separate autonomous systems. You can also call them sub-autonomous systems. Sub-autonomous systems inside the primary autonomous system. According to autonomous system 6, the neighbor autonomous system will be seen as AS2345, not as AS4 or AS5. Likewise, autonomous system 1 will see neighbor autonomous system as 2345, not as 2 or 3. So this autonomous system, the secondary one, the sub-autonomous systems, are not going to be exposed to the neighbor autonomous system. They're not going to be exposed. They all form an alliance and they represent this number 2345. So when you configure here neighbor, don't put autonomous system 2 as a neighbor. No. Don't put autonomous system 3 as a neighbor. No, it won't work. Why? These routers are going to reveal themselves as 2345 autonomous system. So you need to say here the data router is an autonomous system 2345. Not 3. Now, why are we breaking down the big autonomous system into sub-autonomous systems? What is that you achieve through this? What is the benefit of this? You remember that single rule, IBGP split horizon rule, Jana? What is that rule says? The route learned from one IBGP should not be given to another IBGP. That's the issue. To solve that issue, we had one solution earlier, two solutions in fact. One is route reflector, other one is full mesh. See this picture, this is much better. You are learning some routes from the upstream EBGP neighbor. Assume there is no confederation. Assume there is no confederation. The route will go from here to here. The route advertisement that is coming from outside will go from here to here, and also it will go from here to here. And that's all. It won't go further anywhere else. Likewise, the route that is coming from here will go from here to here and to here. That's all. It won't move further. It won't go anywhere else. As a result, what happens? The purpose is not met. The transit autonomous system is not transiting. So no one from here can go to here. Why? The routes are not distributed to them. Autonomous system 300 routes are only up to here. They don't go anywhere else. They're not given to this router. So it don't go to this 200. So 200 cannot ping 300 now. So we need a solution. If I use a route reflector here, the route will get reflected here, no doubt. But if it is too big an autonomous system, only route reflector alone is not enough. You need confederation. And you can have route reflector inside each confederation. For example, you create confederations like this, and if you want, you can have route reflector here, so that route will get reflected. Now, route reflector inside the sub-autonomous system and the sub-autonomous systems are also a solution for the IBGP split origin issue. How? You see, the original autonomous system is 100, but according to this router, even though it belongs to primary autonomous system 100, it also belongs to this sub-autonomous system. This sub-autonomous system number and this sub-autonomous system number are not the same. So what they get is they get an EBGP kind of relationship, even though they all belong to single autonomous system 100. Even though they all belong to single autonomous system 100, because you have sub-autonomous system inside this, between the sub-autonomous system peer, EBGP relationship is coming now. Now you see the route learned from one IBGP will be given to EBGP, no problem. Route learned from an IBGP should not be given to another IBGP, but it can be given to EBGP. In order to get this experience, EBGP experience inside IBGP, you create the sub-autonomous systems. Hope I made it clear and you understood. Let me put it again. If it is single autonomous system, all will be IBGP. And when there is IBGP, there is a rule, route learned from one IBGP should not be given to another IBGP. But when you break into small autonomous systems, between the small autonomous system, they get an EBGP experience. So route given by one one IBGP to another IBGP will be given to eBGP. As a result, the routes gets distributed here, and this will give to eBGP, and this will give to this IBGP because it is getting from eBGP. If it receives from another IBGP, it will not give because it is receiving from an eBGP. It gives. Jana, did you understand? So just to simulate, yes, go. Yeah, go. Now, eBGP relationship solves the problem. That's why we need configuration. Along with this, if you want, you can have route reflector also. See, if you have more routers, lazim you don't have this link, and you got more routers here. Lazim you don't have this. So the route will go from here to here. You can reflect it here. You can use RR, and you can reflect it here, and then this will also get reflected in the reverse path, and this will give to eBGP, no problem, because you have configuration. So you can mix route reflector and configuration and have the reachability. But why are we not using this in the real world? In the yes, but you need to put another route reflector. Hmm, hmm, hmm. You see, if you have more routers, making RR will reflect the route up to here only. Then you need to put another RR here and make this as a client. Now, why are we not using configuration in today's production? Because it is not necessary, needed. Earlier, we were not having VPN as a solution. But now, we don't run BGP like this. We run BGP only on this router and this router. And we form an MP-BGP tunnel. We don't need to even run BGP here. After MPLS layer 3 VPN, the need for configuration is eradicated. It's removed. There is no need. But why are we learning that? If it is not needed, why are we learning it? It is just for your interview. Because the interviewer will not know that there is no need for configuration today. Because he is that clever. That's why he is in the interview panel. He will ask that question. What is configuration? Because it is there in the internet, ready-made questions. What is in configuration in BGP? Okay. Next. The next topic is, okay, before I go, if you have any question on the configuration on the interview perspective, you can ask. Now, in BGP, we also see something called cluster ID. What is that? The router ID of the route reflector server is the cluster ID. See, for example, if you will make this router as an RR, the router ID of this is 3.3.3.3. So whatever the route coming from here, it reflects here. And whatever the route coming here to here will reflect here. So for these two, this is the reference. So this is what the cluster ID of this. These two belong to the cluster group 3.3.3. That is what this forms a group. So they are called as clusters. And the ID for the cluster is 3.3.3.3. Will not be useful for you in the interview, but I'm just telling you. While you configure, this router will be configured with BGP Autonomous System 65001, but internally you will say configuration ID 100. So when it forms EBGP, it will only use this ID. But when it forms IBGP, it will use this ID. You got it? For wherever you have configuration ID same, with them they will share this ID. But for this, it will just advertise this ID as 100. I am 100 speaking. But originally the autonomous system that you configured is this. If you see here, this is router 2. The original autonomous system number is not 24. The original autonomous system number is only 2. But the sub-autonomous system is 24 of router 2. So you configure only BGP 24, but inside you say the configuration ID is the actual autonomous system. Did you understand this? Is it clear now? The original autonomous system, the primary autonomous system is configuration identifier. There is another sub-autonomous system in autonomous system 2. See, 24 and 35, they are of same autonomous system. 35. You see. This is the confederation peer, isn't it? This is also a confederation. This is also a confederation. So you form an alliance, confederation peer alliance. Right? That's all. If you do this, then it is BGP community. Now, what is community? Nothing but group of single common property. You see, the blind community, meaning what? All the blind people. That is what blind community. Youth community, and all youth people. Old age community, all old people. So they all have one in common, what? Their age is old. So they form one group, one community. All are blind. That's what they have in common. So they form another community. Why are we grouping like that? So that when we talk, it will be easy for us to understand. When I use the word community, blind community, and when I speak, whatever I speak is for every blind people. The blind community, they walk upright. They don't put their head down. They see people face to face, even though they don't fight. They take their disability as a challenge. They walk with a stick, with boldness, with a confidence that they will not fall inside a pit. And God is there leading them front, back, left, right, up, down. protecting them. So all that I spoke is about that group of people who don't have eyes to see, blind community. So all that I spoke, those words don't belong to those teenagers community. Teenage communities, even though they have eyes, no strong confidence. They always think that they will sink and they will fall and they will die. That's what they fear. No use of the eyes. Though the blind community don't have an eye, they still have the confidence, courage to face the world without fear, with confidence. So it helps me to address the group of people when I have community, blind community, youth community. It helps me to easily address the people likewise. We learned a lot of attributes. And if I want to set weight attribute for some neighbors, not all neighbors, so I'll group that some neighbor in community and I'll configure weight only for that community. I'll configure local preference only for that community. You see? Even it is for single router, you will be pointing towards multiple neighbors, no? Whenever the route comes from that neighbor, this is the weightage. Anyway, here our aim is not to learn weight, focus on community. To attach an attribute to a group, you need to first group it. For grouping them, you need to provide an ID. That ID is a number, and that number is a community value. If you say community value 300 colon 300 and assign this 300 colon 300 for set of networks that I learned through BGP, and when I say, hey router, when you receive the community 300 colon 300, set local preference 300. So it will be easy for me to set local preference 300 only for this group of network because they're all tied up with one community value. So what is BGP community? It's a numerical value that you have to identify a group of subnets that needs a common treatment. Apart from this, you also have some predefined community. It depends on, it varies from vendor to vendor. There is a community called local AS, internet, blah blah. AS only, something. Here we can see that predefined, well-known communities. Earlier, what I was saying is, we group some networks, we provide them an ID, and to that ID we set some attribute. That is custom community. This is well-known community. What is that? Internet. If you say internet as a community value, it means that advertises the prefixes to all BGP neighbors, both eBGP and IBGP. When you say no advertise, it does not advertise prefix to any BGP neighbor. That's another community. If you say no export, only to eBGP it won't send. To IBGP it will send. Local AS, it will advertise, see, does not advertise the prefix outside the subautonomous system. We just learned configuration. If you want to distribute around within the subautonomous system, within the subautonomous system, not even to another subautonomous, not throughout the autonomous system, within the subautonomous system, then you need local AS. So this fourth one is needed only when you are using configuration. These four are known as well-known. Internet means give to everyone. No advertisement, don't give to anyone. No export means don't give it to illegitimate neighbor. Local AS means don't give even to configuration key. It is only within this subautonomous system. Any question on BGP configuration? So BGP community is sending extra information that can be added to the prefixes that will be advertised to the neighbor. This extra information can be used like traffic engineering, like what we were discussing, attach an attribute and do the traffic engineering. Wherever you give local preference higher for that prefixes that will be like this. That is the kind of traffic engineering. And there are four well-known policies, which well-known communities, which we saw now. Internet, so they're on the top. No export, no advertise, no things. So BGP community, what is my definition? BGP community is an additional or extra information like a tag, numerical tag that you add to one or more prefixes so that those prefixes can be identified with one tag, one number to which I can add attributes for policy-based routing. So that's how I will. We also have well-known communities. If you do not want to advertise, then you say no advertise. If you don't want to advertise to eBGP neighbor, then you say no export. Any question?